Welcome to video 7.3, difference of means or means of differences. Okay, I'm going to give you two scenarios using the same data. In my scenario, there are two versions of a final exam, version A and version B. When I ran the one variable statistics, I got version A had a mean of 87 and version B had a mean of 80. The students who took version B thought maybe version A was easier because the grades were higher. Okay, so what we're going to look at is we have right now our first scenario, 10 students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 of them took version A, 5 of them took version B. So we have two samples. So one group took version A, one group took version B. Okay, so in other words, the scores of A and the scores of B belong to different students, right? So when we have that situation, we have two samples, we're looking for a difference in means. I want to know what their mean difference is of the students who took the A version and the students who took the B version. So to get my statistic, I'll take the mean of A minus the mean of B, and I got a difference of 7. And so we're going to look at the confidence interval and the significance test, how they would set up. If I gave you this problem and I asked for a confidence interval, what you would use for your specific formula would take the mean of A minus the mean of B plus or minus, because this is a means problem, it will be a t-star. And then the formula that you will use is the variance, which is the standard deviation of A squared divided by the sample of A, plus the variance of B, which is the standard deviation of B squared, that's the variance, and then you would divide it by its sample size. So what you're looking for here is an estimate of plausible values. Okay, what is the plausible difference between these two scores? So if I'm subtracting A minus B and I got a confidence interval that was negative, that would mean the B scores were higher. So the people who thought A was harder had no basis because B was actually had higher scores. If I had a confidence interval that was positive, that would mean that the A scores were higher. And maybe they do have a claim here, especially if these versions were randomly assigned to students. We could determine some causation in there, maybe, when we do our significance test. The third option we could have is negative to positive. And so negative to positive would mean you don't know for sure because 0 is a plausible value. And remember when we're talking about is this convincing evidence and we say 0 is in the interval, you would want to follow that up with a reference to the alpha. We don't say what kind of confidence interval we would have, but say I asked for a 95% confidence interval. That means you'd have an alpha of 0.05. A 90% confidence interval would have an alpha of 0.10. So you would want to say, follow it up with, well, using the alpha 0.05, we would reject or fail to reject depending on your interval, whether it was plausible that B was harder. Okay, so that's our confidence interval. Then we had our significance tests. So for your significance test, you'll have to write a hypothesis for your null and alternative. So your null is the mean of A minus the mean of B will be there is no difference. Okay, and the alternative, well, the kids think B is harder, so B would have lower grades, which would make A bigger. A minus B would then be positive numbers. So the mu of A minus the mu of B would then be greater than 0. Okay, and of course you would want to define your parameter, what is mu of A minus mu of B. Then you would find your test statistic. So in this case, it is a t-test because it's a means problem. To get your statistic, remember it's x bar A minus x bar B minus 0 because that is our null. Okay? Divided by, and then we're going to use that same standard error formula where you have to use the variance. The standard deviation of A squared divided by the sample size of A plus the standard deviation of B, and you got to square it, divided by the sample size of B. And then you'd be able to look up a p-value like we've been doing. Okay, so that's if we're looking for a difference of means. I had 2 samples. Okay. A mean difference would be in this same context. I had 5 students. This is student 1, student 2, student 3, student 4, and student 5. And I had them take the final exam twice. One time they took it with version A and got a 90. The second time they took it with version B and got an 83. Student 2, the first time got an 82. The second time got a 77. So it's the same student doing both tests. So we have one sample. Two scores for one student. And you will often see this called a matched pair. Either 2 very closely identical people or items or objects or subjects, or the exact same object subject being given both treatments. In this case, which version of the test. Okay, so to find the confidence interval for the mean difference, we only have one mean. Okay, so we have our confidence interval. So you'll use x bar diff plus or minus your t star. And because this is only one sample, you've got to use the standard deviation of the differences divided by the square root of n. Okay, so you got your point estimate. It's just one number because it's one sample of 5 students, as opposed to 2 samples of 5 students each. For our significance test, we have to have our hypotheses again. So our null would be that the mean difference, that there is no mean difference. Null means none. And your alternative there is that the mean difference is still greater than 0, because if we subtracted in that order, we would get a number greater than 0 if B was harder and had lower grades. To find your test statistic, it's a t, x bar diff, minus 0, because again 0 is the claim right here. And then your standard deviation, this is one sample, so it's standard deviation of the differences divided by the square root of the sample size. Okay, hopefully that was helpful in kind of getting the subtleness between difference of means or mean difference, because they are 2 very different problems. Let me know if you have any questions. I'll see you in class.